morning children. In today's class we are proceeding to a new concept called concavity. You have already learnt in science concave, convex, mirrors, lens, all that. Here mathematically we are analyzing a curve, whether it is concave up or concave down. Alternatively, whenever the curve is concave up, we will otherwise say convex down. Similarly, concave down tells us convex up. So let us stick on to one particular word to avoid confusion. Concave up, when I say, given a curve diagram like this, draw the tangent at any point on the curve. Wherever the point is, if I draw the tangent, the curve is below the tangent, I will say concave down. Whenever the curve is below the tangent, I will call it concave down. Here, the curve is above the tangent. Wherever I draw, here also I can draw and check the curve is above the tangent. So this I will call concave up. So if you are given a curve, I can easily find out this. Again, down to up or up to down, whenever it changes, that is, there will be a point where it changes from concave up to concave down or concave down to concave up. That particular point where it is changing, we call point of inflection. Now given a curve, I can draw tangent and check whether it is down or up, all that. If you are given an equation without even drawing, I can guess whether the curve is up or down using the criteria f double dash less than 0 tells me concave down. F double dash greater than 0 tells me concave up. So in an open interval, say AB, find out f double dash. If it is below 0, it is concave down. If it is above 0, it is concave up. And whenever f double dash changes sign from plus to minus or minus to plus, that particular point we call point of inflection. For point of inflection, we can also say f double dash equal to 0. Certain cases, f double dash does not exist also. Even if f double dash doesn't exist, we will get point of inflection. So check the problems properly, finding f double dash. In other words, I can say f double dash positive. In other words, f dash increasing function. F double dash less than 0 tells me f dash decreasing function. So if I write like this also, the meaning is concave up and concave down. So in the exercise problems, what are we supposed to do? Find out first derivative and then second derivative. Put the derivative 0. Check f double dash greater than 0, less than 0 intervals. As we did in increasing, decreasing, for f dash, we will do the same procedure but now for f double dash. And we will check where f double dash is changing the symbol. Where and all it is changing the symbol. Declare the point as point of inflection. Notice, point of inflection need not be a stationary point. Stationary point condition, f dash equals to 0. Point of inflection, f double dash less than 0 to greater than 0, it is changing the symbol, or greater to less, it is changing the symbol. Let us proceed with the exercise problems. Exercise 7.7, find the intervals of concavity and points of inflection. F of x equals x minus 4 the whole cube. We have to find the second derivative. So let us find f dash of x first. How many terms are here? 2. Keep the first term. Differentiate the second term. 3x minus 4 the whole square. Plus keep the second term. Differentiate the first term. So keep x power 3. Remember the formula, x power n derivative n x power n minus 1. As I apply, x minus 4 power 3 will become 3x minus 4 square plus keep x minus 4 the whole cube, x will become 1. In both the terms, see what is common? X minus 4 the whole square. What is remaining? 3x plus x minus 4, or I can say x minus 4 the whole square into 4x minus 4. The next step, find out f double dash of x. What do you mean by f double dash of x? This answer we differentiate again. Again there are two terms. Keep the first term, x minus 4 the whole square. 4x will become 4. This 4 constant will become 0 plus 4x minus 4 into x minus 4 the whole square will become 2 into x minus 4. Keep the first term, differentiate the second term plus keep the second term, differentiate the first term. In both, see what is common? 2 is common. Take it out. X minus 4 is also common. What is left out? If I take 2, 1 2 is left out. 1 x minus 4 is left out. 2 into x minus 4 we have taken. 4 into x minus 4. This will be 2 into x minus 4 into 2x minus 8 plus 4x minus 4. Together 2 into x minus 4 into 6x minus 12. 2 into x minus 4 into 6 common x minus 2. So we are left with 2 into 6. 12 into x minus 4 into x minus 2. This is f double dash of x. Put f double dash of x equal to 0. Putting f double dash of x equal to 0, we get 12 x minus 4 into x minus 2 0, or x is equal to 4 and 2. Mark it in the number line to get the intervals. It is minus infinity to plus infinity. Out of the 2 points, the small one will come first, the big one will come second. How many intervals we get? Minus infinity to 2, 2 to 4, 4 to infinity. We have 3 intervals. The first interval, minus infinity to 2. Put a value inside this interval. Before 2, I can put x is equal to 1. 2 to 4, I can put x is equal to 3. Any value you can put. Let us put some easy values. After 4, I can put x is equal to 5. Substitute the values in f double dash. What is f double dash actually? 12 x minus 4 into x minus 2. As we substitute 1, 12, 1 minus 4, 1 minus 2. Check whether it is positive or negative. 1 minus 4 is negative. 1 minus 2 is also negative. Negative into negative, we will say positive, and therefore it is concave up. The next number 3, as I substitute 12, 3 minus 4 into 3 minus 2. 3 minus 4 negative. 12 is always positive, forget it. 3 minus 2 positive. Minus into plus, it is minus. So we will say it is concave down. The next idea, it is 5. As I substitute 5, 12 into 5 minus 4, 5 minus 2. 5 minus 4 positive, 5 minus 2 also positive. Plus into plus, it is positive, and so concave up. So we can take and write the answer. F of x is concave up in minus infinity 2 and 4 to infinity. F of x is concave down in 2, 4. So where is the point of inflection? Check. Up to down, it is changing at 2. So, point of inflection at x is equal to 2. Also, down to up, it is changing at 4. So, here down, here up, common number 4, write x is equal to 4. Find the point of inflection. Tells me find f value also. As x is equal to 2, f of x is minus 16. So the point is 2, minus 16. When x is equal to 4, f of x is 0. So the point is 4, 0. And for this problem, we have 2 points of inflection. Hence, we conclude f of x is concave up in minus infinity 2 and 4, infinity. It is concave down in 2, 4, and the points of inflection are 2, minus 16 and 4, 0. Exercise 7.7, question number 1, subsection 2. F of x equals sin x plus cos x. To find intervals of concavity, we need to find the second derivative. F dash of x. Sin x becomes cos x becomes minus sin x. The next derivative, f double dash of x. Differentiate this again. Cos x becomes minus sin x becomes cos x. Putting f double dash of x equal to 0, minus sin x minus cos x equals to 0, or minus sin x equals to cos x, or minus sin x by cos x equals to 1 as we divide. Tan x equals to minus 1. When tan x is minus 1, we have the 4 quadrants 1, 2, 3, 4. Tan x is positive in first and third quadrant. So tan negative tells me we are in second and fourth. How to write second quadrant? 0 to 2 pi is our interval. Second and fourth quadrant tan is negative. So second quadrant is pi minus theta. Fourth quadrant is 2 pi minus theta. When tan is plus 1, it is pi by 4. Minus 1 tells me pi minus pi by 4 or 2 pi minus pi by 4. 4 pi minus pi, 3 pi by 4. 8 pi minus pi, 7 pi by 4. So the interval as they have given 0 to 2 pi. We divide using these values 3 pi by 4 and 7 pi by 4. Let us write the interval x value and f double dash sign and check the concavity. The interval we get 0 to 3 pi by 4. Next interval 3 pi by 4 to 7 pi by 4. Next interval 7 pi by 4 to 2 pi. How to find x value? It is crossing 0 to 3 pi by 4 here. So definitely in between I have 30, 45. So whichever is convenient for you, you can substitute. 0 to 3 pi by 4, x value pi by 2. 3 pi by 4 to 7 pi by 4, x value pi. 7 pi by 4 to 2 pi, x value. This is 2 pi minus pi by 4. So we shall put 2 pi minus pi by 6. As I substitute in the second derivative, which is minus sin x minus cos x. Sin 90 is minus 1, cos 90 0. Sin pi 0, cos pi minus 1, minus into minus 1. That is plus. This is minus 1, so it is negative. Here it is positive. Here sin in fourth quadrant negative. So minus half will come, minus into minus plus. So plus 1 by 2 minus cos in fourth quadrant positive only. Cos pi by 6 root 3 by 2. 1 by 2 minus root 3 by 2 is also negative. So what will you say about the concavity? Here it is concave down. So we are telling about concavity. Here it is concave up. Here it is concave down. So as we take and write the answer. F of x is concave up in 3 pi by 4 to 7 pi by 4. F of x is concave down in 0 to 3 pi by 4 and 7 pi by 4 to 2 pi. Where does it change? F double dash changes from minus to plus. Common point 3 pi by 4, that is a point of inflection. Similarly, F double dash changes from plus to minus 7 pi by 4. So, points of inflection we get at x is equal to 3 pi by 4 and 7 pi by 4. Substitute x is equal to 3 pi by 4. Get f of x. F of x is sine 3 pi by 4 plus cos 3 pi by 4. Sine 3 pi by 4, it is second quadrant, sine is positive plus 1 by root 2. Cos in second quadrant negative, it is minus 1 by root 2, so my answer is 0. When x is equal to 7 pi by 4, f of x is equal to sine 7 pi by 4 plus cos 7 pi by 4. This is in fourth quadrant, sine negative. So my answer is minus 1 by root 2. This is in fourth quadrant, cos is positive. So my answer is plus 1 by root 2. Again the answer is 0. So we get the points of inflection 3 pi by 4 0 and 7 pi by 4 0. Subsection 3, f of x equals 1 by 2 e power x minus e power minus x. Find out the first derivative half as it is a simple derivative. E power x becomes e power x minus e power minus x becomes minus e power minus x. So together it is half e power x plus e power minus x. When we do the next derivative, it is f double dash of x 1 by 2. E power x becomes e power x. E power minus x becomes minus e power minus x. Putting f double dash of x equals to 0. Half e power x minus e power minus x 0 or e power x is equal to e power minus x. We can rewrite it as 1 by e power x cross multiplying e power x into e power x. Add the powers. X plus x is 2x. E power 2x is 1 tells me x is equal to 0 because we know e power 0 is 1. The next step. Divide the number line. Minus infinity to plus infinity. In the middle we have 0. How many intervals do we have? 2 intervals. What are the 2 intervals? Minus infinity to 0, 0 to infinity. Find out some x value. Before x 0 I can put minus 1. After 0 I can put plus 1. The next step, find out f double dash of x. F double dash of x is half e power x minus e power minus x. When I put minus 1, I get half e power minus 1 minus e power plus 1. E, the value will be an irrational number between 2 and 3. So, e power minus 1 will be 1 by 2 point. This is 2 point. So, definitely this is below 0. The symbol is negative. We will say concave down. The next idea, when I put plus 1, I get half e power 1 minus e power minus 1. Again, this is 2 point something. This is 1 by 2 point something. Definitely greater than 0. It is positive. It is concave up. So, down to up when it is changing. Negative to positive when it is changing. We say it is a point of inflection. What is the common point? 0. So, these imply point of inflection at x is equal to 0. All this, let us take and write the answer. As we take and write the answer, f of x is concave up in 0 infinity, concave down in minus infinity 0. Point of inflection is at x is equal to 0. When x is 0, f of x is half e power 0 minus e power minus 0. E power 0, 1. E power minus 0 means 1 by e power 0. That is also 1. 1 minus 1, 0. So, we get the point of inflection 0, 0 and that is the answer.